This is the first video for section 3-2 in accelerated geometry, which is on multiplying and dividing rational expressions. Today, we're going to focus on multiplying them. And the essential question, both for today and for the next video, is how can you simplify rational expressions? We only have one vocabulary word for this section, which is rational expression. So logically, this next fill in the blank, you can probably figure out what goes here. So a rational expression is a quotient of two polynomials. One example of a rational expression would be the inverse variation from section 13-1. So y equals k over x is a rational, actually that's a rational equation. So if I just wrote k over x, that would be a rational expression. But any two polynomials written in a fraction, basically, are a rational expression. For example, x plus 2 over x squared minus 9. That would be a rational expression. X plus 2 over x squared minus 4 would be a rational expression. If you look at this one, you may think, well, but that's factorable, and that's a factor of x squared minus 4, so it can actually be simplified farther. And even if I write x squared minus 4 over x plus 2, that's a rational expression, but it can also be simplified. And in the process of simplifying that, it's not even a rational expression anymore. So that's actually what we're going to start with talking about today, is simplifying rational expressions. So for both of these problems, we're going to simplify as far as we possibly can, and then we're also going to identify any x values for which the expression would fail to exist, where it would be undefined. And we'll talk about that when we get done with the simplifying part. So number one here, we're going to start pretty simply with, and this should be something that's familiar to you. When you have just two terms written on top of each other like this, I suggest treating the numbers separately from the variables. So just look simply at 10 over 6. If you were going to reduce a fraction that was 10 over 6, you would just look for a common factor to divide both numbers by. So 10 and 6 are both divisible by 2, so both of those numbers can reduce to 5 over 3. And then, if you remember from studying exponents, if you have two like bases, so in this case they're both x's, then you take the exponents and you subtract them when they're being when the bases are being divided. And when you subtract, you always do big number minus little number, and the answer is written wherever the big exponent was in the original problem. So since 8 is bigger than 4, I know that my answer is going to go on the same level as x to the 8th. So 8 minus 4 leaves me with x to the 4th. So this would be my simplified answer, 5x to the 4th over 3. Now, once we have it simplified, we need to identify x values where the expression would be undefined or fail to exist. To do that, you actually need to go back to the original expression. Remember, think for a minute about what you can never have in the denominator of a fraction. You can never have the denominator of a fraction equal 0. So when you're looking for x values for where a rational expression is undefined, you're basically just looking for what x values would make my denominator equal 0. So in this particular one, since it's 6x to the 4th, the only way that 6x to the 4th could equal 0, you can solve that if you want, but hopefully you can figure that out. If I 4th root 0, I just get 0. So if x was to equal 0, this original expression would not exist. So that's my domain restriction. So I'm going to write 5x to the 4th over 3, and then I'm going to put a comma and say that x cannot equal 0. Even though if I use 0 in the simplified form, it would work. I would still be able to evaluate it, but that's not what matters. What matters is where I cannot evaluate the original expression. Okay, so there's your domain restriction. Now let's look at number 2. On number 2, I have more than one term in the numerator and in the denominator. So these are actually going to simplify by factoring. So you're going to put your factoring skills to major use in this unit. So I'm going to start with x squared plus x minus 2. And think for a minute about how that would factor. I want to find two numbers that multiply to -2 and add to +1. So that would be x plus 2 times x minus 1. And then I'm going to do the same thing in the denominator. I want two numbers that multiply to -3 and add to +2. So that would be x plus 3 times x minus 1. And on that factoring, you can think it through in your head like I did. You can make yourself a little tic-tac-toe board off to the side and do the tic-tac-toe method, but I would do that on a scratch piece of paper because I really don't need to see that as your teacher, that that's how you came up with the factoring, because most of us should be able to hopefully at this point factor it in our head. Once you have these factored, though, hopefully it should occur to you that, oh, now I have common factors. Just like in the first problem here with just the single terms, common factors can be canceled out. So these two things are going to cancel each other out, and your final answer is x plus 2 over x plus 3. Now, you do still have to do your domain restrictions, so go back and look at the original denominator before you took out the common factors. So if x plus 3 was to equal 0, the whole denominator would equal 0. And if x minus 1 was to equal 0, the whole denominator would equal 0, which would cause my original expression to be undefined. So just set each of your factors equal to 0 and solve. So for this particular problem, I have two domain restrictions. X cannot equal -3 or +1. Okay, and if you print these notes, then that's awesome because you have this great big huge bold caution reminder that when you're identifying the values for which a rational expression is undefined, you're identifying the values of the variable that make the original denominator equal to 0. It always goes back to the original. Okay, so let's look at one more simplifying problem here. And we're going to do it pretty much the same way we did number 2. We're going to start by factoring this. So in my numerator, I notice that there's a common factor. There's an x in both terms. So I'm going to start with that common factor. If I factor an x out of 4x, I'm left with 4. And if I factor an x out of x squared, I'm left with x. So there's my numerator factored. Then for my denominator, since it's x squared, that's x times x. And then I want two numbers that multiply to -8 and add to -2. So that would be -4 and +2. So now I'm looking at this and I'm thinking, well, I don't have any common factors that I can cancel out. But these two things look an awful lot alike. In fact, if I factor a -1 out of this 4 minus x, if I factor a -1 out of there, that becomes a positive x and a -4 because it would just change the signs of what's in the parentheses. And now I have common factors. So that's a little bit of trickery there. So in the numerator, you cancel out the x minus 4 from both the numerator and the denominator. In the numerator, you have x times -1, which is -x. And in the denominator, you have x plus 2. And then don't forget to go find your domain restrictions. So that would be when the factors of the denominator are equal to 0. So x equals 4 and x equals -2. So your domain restrictions would be that x cannot equal +4 or -2. All right, so I want you to pause this video for a few minutes, and I want you to work numbers 4, 5, and 6 on your own, and then we'll come back and check. Okay, so I'm just going to read for you what these three answers should be. For number 4, it should have simplified pretty simply to 2x to the 9th, and you do have the domain restriction that x cannot equal 0. On number 5, you could not factor the numerator, but the denominator would factor to 3x plus 4 times x minus 1. Cancel out your common factor, and you end up with 1 over x minus 1, where x cannot equal -4/3 or +1. On number 6, both the numerator and the denominator could be factored. The numerator factors to 3x plus 2 times 2x plus 1. The denominator factors to 3x plus 2 times 2x minus 3. All of that reduces to 2x plus 1 over 2x minus 3. Your domain restrictions are that x cannot equal negative 2/3 or positive 3/2. Okay, so that covers simplifying. Simplifying is where you're just given the rational expression, you have to factor and take out common factors. Now we're going to move to multiplying. I don't know why that did that. There are 4 steps to multiplying rational expressions. The first thing that you would want to do is to take all of your expressions and factor the numerators and the denominators completely. Then, out of all of those common factors in all the numerators and all the denominators, you cancel out the common factors. That means that if you have a factor in the numerator and in the denominator, they can be canceled, not 2 in the numerator or 2 in the denominator. Then, you multiply your numerators together, multiply your denominators together, and then double check that those final numerators and denominators have no common factors other than obviously 1. So let's put those 4 steps to the test. I have here to begin with on number 6, 3x to the 5th over y cubed over 2x cubed y to the 7th times 10x cubed y to the 4th over 9x squared y to the 5th. Now, in terms of common factors, these aren't really things that are factorable. When we get down to number 8 and in future problems, your polynomials in your numerators and your denominators may be factorable, but these are all just individual terms. So the first thing that I'm going to do is just focus on each expression at a time and try to simplify it before I ever worry about multiplying it by any of the other expressions. So with this first rational expression, I'm going to start with the numbers. 3 over 2 cannot be reduced, so I'm going to leave it as 3 over 2. And then I'm going to go to the x's. X to the 5th over x to the 3rd becomes x squared in the numerator. Y cubed over y to the 7th becomes y to the 4th in the numerator. So that is the simplified form of that first rational expression. Then I'm going to move to the second one. 10 over 9 cannot be reduced, so I'm going to leave it like it is. X cubed over x squared becomes x in the numerator. Y to the 4th over y to the 5th becomes y in the denominator. Once you have the individual expressions simplified, now we can look at simplifying between the two of them with any common factors before we multiply everything else that's left. What I mean is, for example, this 3 in the numerator can cancel or simplify with this 9 in this denominator. If I take 9 and divide it by this 3, I'm left with a 3 down here and nothing up here. Same thing with the 2 and the 10. 2 will divide into 10 and leave a 5 right here. Notice I have 2 x's, but they're both in the numerator, so I can't simplify. And I have 2 y's, but they're both in denominators, so I can't cancel anything out, only if they're on separate levels of the expression. So now that I've canceled out everything that I can, I'm going to multiply everything that's left, and you multiply everything across the top and then everything across the bottom. So in terms of numbers, the only number I have in the numerator is a 5. With variables in the numerator, I have x squared times x. Remember, you add your exponents, so that would become x to the 3rd. In the denominator, the only number I have is a 3, and then I have y to the 4th times y to the 1st, which is y to the 5th. So now everything has been multiplied. I'm just going to do one double check that nothing here can be simplified. 5 over 3 cannot be reduced. I only have one x variable. I only have one y variable. That's how I know that I'm done. I should only have one of each kind of variable when I'm done. Okay, so then on number 8, we're still multiplying, but I'm going to need to do some factoring before I can do some multiplying. You actually factor and pull stuff apart, and then you end up putting what's left back together when you multiply it out. So in the first expression, for example, x minus 3 cannot be factored. But if I go look at the denominator, these two terms have a common factor of 4. And if I factor out a 4, I'm left with x plus 5 right there. Then in my second rational expression, the x plus 5 is not factorable. But x squared minus 9, if you remember that's a difference of two squares, it factors to x plus 3 times x minus 3. So now I'm going to look across all of my expressions for common factors. One in the numerator should match with one in the denominator. For example, this x minus 3 matches this x minus 3 in this denominator. This x plus 5 matches this x plus 5 in the denominator. And now I'm completely out of anything in the numerator, so I know there's nothing else left to factor. And when everything in the numerator is gone, that doesn't equal 0. It equals 1. And then everything that's left in the denominator is a 4 and an x plus 3. Now, it's okay to leave your answer in factored form like that, but typically we then multiply everything that's left back together, and so that would be 1 over 4x plus 12. Okay, so I want you to take a minute, pause it, and try numbers 9 and 10. Okay, so my number 9 looks kind of messy, so let me talk you through my thought process. The first thing that I did was I reduced the expressions individually. The only one that I could reduce was the x to the 7th over 2x. I was able to divide this x into x to the 7th, and it became x to the 6th over 2. That was before I ever really got started with combining everything together. Then, in all the blue pen, was me canceling out common factors from expression to expression. I started with the 2. 2 went into 20 and reduced it to a 10. But then the 10 and the 15 were both divisible by 5, turning the 10 into a 2 and the 15 into a 3. So that's where the 2 over 3 comes from. Then I took the x to the 4th and divided it into the x to the 6th, which became an x squared. So that wiped all of my x's out of my denominator. So the only thing I was even left with in the denominator was a 3. In the numerator, I had an x times x squared, which is x cubed left. Now let me say something about this. This is a mess right here. If you're not able to follow all that or do all that on the first time around, that's perfectly fine. It's quite that maybe you figured out that, okay, 2 goes into 20 and that's a 10, so I have 10, and then x times x to the 6th is x to the 7th, and then 15, x to the 4th. You might have gotten to this step, but then hopefully you took a minute right here and said, oh, wait a minute, 10 over 15 reduces to 2/3, and x to the 7th over x to the 4th reduces to x to the 3rd. You don't have to be able to do it all at one time like that. It's perfectly okay to go step by step. Then on number 10, I started by factoring everything. 10 times x minus 40, I took out a common factor of 10, and that left me with x minus 4. X squared minus 6x plus 8 factors to x minus 4 times x minus 2. X plus 3 is not factorable. 5x plus 15 has a common factor of 5, which left me with x plus 3. So I was able to cancel out x plus 3's, x minus 4's, and 5 goes into 10 with 2 left over. So in the numerator, the only thing I even had was that 2, and in the denominator, the only thing I had was x minus 2. So all that junk, when I multiply it out, I end up with 2 over x minus 2. Hopefully the simplifying and the multiplying is making sense to you. It's just lots and lots and lots of factoring. So if you didn't get on that boat the first semester, now's your chance.